Can AI actually measure aim? Yes, it can. But the real question is, can AI actually measure good aim? I spent the past 6 months trying to find out, and it was harder than I ever imagined. My name is Tim Young, and over the past year, I've spent $100,000 of my own money building the beta version of my AI Valorant coach training arc. The beta has been focused on analyzing gunfight hygiene, and I can't believe the response it's gotten so far. And stick around, because at the end of this video, I'll tell you how you can be a big part of this project. But for training arc to be everything I dreamed it could be, I need to do two things. One, I need to find a way to break down and classify a gunfight into bite-sized pieces that an AI can actually interpret. And two, then I need to use AI and computer vision to measure crosshair placement to give analytical feedback. And spoiler alert, it is way harder solving these than I ever thought it was going to be. Most of us have an idea in our mind when we think of the term crosshair placement, but it's actually challenging to define out loud and in a way that AI can actually interpret. Let's look at these two players. I think we can all agree that the one on the left has good crosshair placement and the one on the right has pretty bad crosshair placement, right? But up until now, all we've been able to do to identify good crosshair placement is apply the Potter-Stewart approach, which is we'll know it when we see it. And while that is true, it doesn't help anyone get measurably better. So how do we even break this down? Crosshair placement is how good your crosshair is placed for the beginning of a gunfight. But what is good crosshair placement? Is it just keeping your crosshair at head level? Well, it's more than that, because if you consistently hold too close to an angle, you're never going to have the reaction time to click on someone's head. And it's not just generally having your crosshair in the right location as you peek. And that's where I came to my first light bulb moment. There's really two scenarios we need to figure out here. You're either holding or you're peeking. So let's dive into holding. We hold an angle, we guess the location where the enemy is going to strafe out of, and we make a guess as to how wide we need to hold, and then the gunfight happens. Did we hold too low or too high? We can know that depending on where our crosshair is relative to the first shot we take. At first, I thought we were going to get AI to say whether your crosshair placement was good or bad, but what happens if everyone at your elo swings wide and everyone at high elo has a tight deady peak? Well, then our crosshair placement needs to account for that. That's really difficult for AI to figure out. But this was the epiphany for me. We shouldn't measure good or bad. We should measure what happens. And if we measure where your crosshair placement is relative to the beginning of the fight, your first shot and the enemy head location, well, we now have a framework of how good your crosshair placement is. If all of those things line up 100%, your initial crosshair placement is where their head is. When you shoot, your crosshair placement is perfect. You've turned Valorant into a click timing drill in aim labs. If you had to adjust or move, or you held too close, then we can begin to break down where your crosshair placement fell short and specifically why. We can do the same thing for peeking an angle, except the difference here is that your setup, your crosshair's placement, happens before you peek the angle. If you're wildly readjusting your mouse as you peek, and you know who you are, then that's pretty bad. You want to ideally be aiming with your keyboard, and then we can see how your crosshair at the end of the peek lines up with the enemy head. If you pre-aim and guess well and control your peek perfectly, these things will line up 100%. And if they don't, well, then we have something to measure. It gets more in depth than that, and there are corner cases and more to break down, but at its core, that's what crosshair placement is. Did you set up your crosshair to accurately take your first shot? And if we can begin to measure that, we can tell you where you're good and where you're bad. So great, now we know what to tell the computer, but that doesn't mean the computer can do it. So now that I've theory crafted the what of crosshair placement, now I need to try and go do it. And this shouldn't be too hard, right? Well, it turns out you can't just run this through ChatGPT or Gemini and tell it to rate the quality of the crosshair placement. The biggest problem is that these models aren't trained on this type of data. They also can't give the type of precise feedback that we need for this to be useful at all. So I decided to start with what I thought was the simplest. Try to detect the first frame that an enemy appears. So I took one VOD and I pulled out every single gunfight clip. Then I went through each gunfight and manually tagged the first frame that the enemy appeared. This is so we have something for the initial guess to test itself against. We'll get back to this later. So I got ChatGPT to help me figure out how to test this out. And it suggested I first use OpenCV to try to find the first frame. And this was hopeless. It couldn't do anything. OpenCV can't make heads or tails of what's happening. And so I went back to ChatGPT and I explained this didn't work. And it said, of course it couldn't work. It didn't didn't understand and we need to do something else. And it would have been nice if it told me that from the get-go. So then we used a different mix. We used a mix of a ResNet RGB image and YOLO as feature extractors. And then we put it into an MLP classifier. There's some technical explanation needed if we get into this. So first off, what is a feature extractor? A feature extractor is something that accepts an input, in this case an image, and outputs the information in a different way. Typically, we don't train the feature extractor. ResNet RGB image and YOLO are feature extractors. YOLO stands for you only look once, and it's already trained and supposed to be able to detect Valorant models. The MLP classifier is the thing that gets trained here. It accepts the input from the feature extractors, and then it makes a guess as to which frame was correct. This gets compared against what I manually marked as correct. You'll remember I did that at the beginning of this section. The difference between what is guessed by the MLP classifier and what I manually labeled as correct is called loss. The MLP classifier then gets tuned on the data to minimize the loss. For those of you who have done it, this is really similar to a linear regression. So awesome, we do all this and we should be good, right? Nope. Well, what's wrong? Well, this is where I realized that while YOLO has a lot of positives, it means that it guesses right and it is right. It also has a ton of false positives, greater than 50% at times. Half the time, it will identify the ground as an enemy. Not very helpful. The other problem is that YOLO has trouble telling the difference between an enemy and a teammate. Again, not great. So, okay, back to the drawing board. I decided then maybe we should try adding a crop of the minimap as well. And that should aid us because enemies always pop up on the minimap. And this is where I learned something interesting. We often think that when someone is on your screen that they appear immediately on your minimap. And while that's kind of true, what I realized it isn't exactly. In that when you actually go frame by frame, when you see an enemy, they actually don't pop up on your minimap immediately. There's often about 4 frames where you can see them. So about 60 milliseconds. They'll be there on your screen, but they won't yet be on your minimap. So it is almost immediate, but it's not exactly. So now we have an RGB image, the screenshot of the whole image. We have YOLO, and we have this minimap crop as feature extractors. And we're going to send all of this information into the MLP classifier. And so I run it again and no bueno. Basically, we repeat this over and over again, and I begin to realize I don't know what I'm doing. I'm trying to build something with no idea of the landscape. I'm taking ChatGPT on its face here, but I realize at this point I actually kind of need to know what I'm doing. I need someone who knows what they're doing. I need someone who can read what ChatGPT is outputting here and call BS or not. There you have it. After months of studying and coming up with these 3 huge takeaways. Number 1, how to classify and break down crosshair placement. 2, how to measure crosshair placement. And 3, that I can't build this myself. I need help. But that's okay, because now I can guide someone to help implement this into Training Arc, and I wouldn't have been able to say that before I started this challenge. And just because we hit a wall doesn't mean Training Arc won't have these features. I believe now more than ever that this is actually possible, and I'm not stopping until it's part of the program. The next step is finding the right person to actually help me bring this to life, because Training Arc won't be complete until AI can teach you how to actually aim. So I'm coming to you, because I'd rather give this job to someone in the Valorant community than anywhere else. If you think you can help with the next steps, or you know someone who could, I've created an application link below. Fill that out and send it in. And if you want to join the beta and have Training Arc improve your gunfight hygiene at the lowest price it will ever be, there's a link in the description. If you want to see a demo of the Training Arc beta in action, then you need to watch this video next.